Hello, everyone. It is my great pleasure to welcome you all for our next NGS seminar. Just a quick word. So, as you probably know, by the end of this month, exactly on the 24th and 25th of September, we are holding our virtual NGS symposium. You are all welcome to join, even though abstract submissions for short talks are already closed. It doesn't matter. You are still welcome to join oral talks. You can find the program on our website, and detailed instructions how to join will be posted on our Discord. So don't miss it. I think it's going to be great. And for today's NGS seminar, it is my great pleasure to introduce Karolina Sienkiewicz. Karolina is she graduated with a master's degree from University of Warsaw, where she worked as a part of Regulatory Genomics group. For her thesis, she developed genomic data visualization methods for reproducible science. Right now, Karolina works as a software engineer at the Center for Public Health Genomics at the University of Virginia, and her main topic is investigation of new methods for multi-omic data integration with a non-negative matrix factorization and molecular subtyping. That's a handful, but she's great, and the topic is awesome. As for the NGS symposium, as for her NGS school work, she is a coordinator for the Virtual NGS Symposium. She's also involved with NGSeminars, and in general, she does a great work as a part of NGSchool. So we are very, very happy to have her give today's talk, which is entitled, as you know, for Data Science with tidyverse and ggplot. So, Karolina, thank you very much for sharing with us, and the floor is yours.
Thanks, Natalia. I'm very happy to be here and give you this seminar. So let's start maybe by let's see. Okay, so you can join the seminar by going into the Discord, into the R channel, and then you can ask me questions. If somebody could just confirm that everybody can hear me now and see my screen, that would be great. And then we can start. Okay, I see all the yeses from start to beginning. Okay, great. So this seminar is in general meant to both people who have never worked with tidyverse and people who want to just try to make their life easier in general with their work with data exploration in R. If you never worked with R before, I would greatly recommend that you look into our previous seminar, Intro to R, where Maya explained some of the basic stuff about R, basic data types, and the problems that may arise when you are working with R. So please look at this if you can. In general, if I am of the opinion that tidyverse should be taught to everybody who is starting to learn R. So you should be able to follow this tutorial, this workshop anyway. But if you have any questions, please refer to this previous seminar, and then if you have any questions afterwards, please join the Discord and ask the questions on the R channel. This is a great community, and everybody will be happy to help you. Okay, so could you please, if you want to follow the seminar just alongside me and run some of the code by yourself, please go to the GitHub page. Here's the address. The address should also be, I think it's, thanks, Ula. So it appeared in the in the both channel and presumably the YouTube. It is not important to follow it, to click through it right now. It's much more important for me that you focus on this and focus less on specific comments and more on how to think about your data, how to prepare your data for plotting, and how to think about plotting. So this seminar in general is meant to be something you can fall back on later on when you have some issues. All right, so here on the main page, there's some information about a setup if you want to follow along. I'm going to be using a local setup, a local RStudio, and you can easily do it by just cloning or landing and unzipping this repository. So you need to go here to the code and download the repository, or clone it with Git, and installing required package below. If you want to follow, if you don't have access to RStudio and you still want to follow, you can do it by accessing RStudio on the cloud. Here is a link. It's free and it works pretty well. And you can easily just start a project from Git repository. So we will need to copy a URL to this repository into the RStudio on cloud, and then all of the files will be there. If you want to follow along, please install these packages right now when I'm going to be talking about, I will be talking about some introductory stuff first off. In general, there is only one file we need to follow. It's our Markdown file. And later on, if you want, you can add some of your notes and compile it into a PDF file with all the helps for the tidyverse and ggplot2 will need. Okay. So I think everything looks good. There is also a bit of images here and one test data set. So this repository will be needed, and not only this RMD file. Okay, so let's see. Let's start. Okay, so this is our RMD file. Let's see. What is a tidyverse? Tidyverse is actually not an R package. It's a collection of packages. It's a collection of tools that is very that is meant to be a tool set of the data scientists. So it's very good for data exploration. And the core of tidyverse right now is about 8 packages. One of them is ggplot. So actually, the title of this seminar is a bit repetitive because we already, by using tidyverse, we can use ggplot. But we just wanted to highlight that we're going to talk about visualization as well. So it's not very important right now what packages are doing what. The most important part is that they share data structures, like table, a main data structure we're going to talk about a bit more in a moment, and mutual grammar. So they are the same rules. What does it mean that the package has grammar? Grammar in general, it's a collection of syntax, language syntax rules. So this is a collection of rules that allows us to use all of these packages in the same way. So everything is meant to be released together and be compatible. Right, so we have packages for visualization, for this main grammar, for mutual data types, reading files, everything you need for the data exploration. So other than this, I think it is very good to use tidyverse. So, like I mentioned, to talk tidyverse to beginners, because it seems to have a low entry threshold. It's actually, you need to just figure out how to use a couple of basic commands, and then you are able to do everything you want with your data set. And in general, it has a database-like approach. So if you are, for example, familiar with SQL or some other database management software and data management languages or protocols, you should be able to follow without problem, because in tidyverse, we are going to treat our data as a database. So we're going to run the same familiar commands on our data table. If you are not familiar, don't be afraid. It's not that complicated. We're going to see in a moment. Yeah, and tidyverse includes also ggplot, so we can have very aesthetically pleasing visualizations. Even though I am mainly a Python programmer, I still believe that ggplot, most of the ggplot plots are superior, mostly because of again the grammar we're going to talk about a bit more, and the fact that they're very easily customizable, so we can do whatever we want with them. Yep, and of course, tidyverse is used all around the world. It has a big community and great resources. So if you need some more help, it's very easy to find help online, and you can even find it on our Discord. Yeah. Okay. So we're going to start by just attaching our tidyverse. As you can see here, there is a couple of warnings here. We can mostly ignore it, especially this one, because this is my R compatibility warning. It's fine, it still works. What is most important here is that we have all of the versions of packages we are using in tidyverse. And the most important part is here. So there are conflicts on names. Generally, the more libraries you attach before attaching tidyverse means it's more likely that you will actually have some conflicts. It's actually not a problem, so don't be afraid. Just take an account of what is here, and if you need to run one of these functions, you still can. So let's see here. If you want to run, so right now, filter from the dplyr package and filter from stats package are in conflict. So if we try to use filter function, it will actually run a dplyr function. And if we want to run a function from stats package, we just have to specify that we want to run a function actually from the stats package. So the filter function here. So by running this function, we are still running stats function. So it's, in general, it's not a problem. It's a very useful information for later. But maybe not always you want to see this, especially if you write a script from when you run a script from the command line. Maybe sometimes you don't want to see this message, so this is a pretty nifty comment that allows you to suppress it. And speaking about running scripts from the command line, in general, I hardly recommend it. Yeah, so in general, I recommend using tidyverse, but there's a couple of instances when using a tidyverse is not a good idea. And one of them is if your dataset is very, very large. So as large that even reading it in basic R will take a lot of time. So for example, we have methylation informations from methylation 450, which means that it's a very, very large matrix. Then you should probably look into data table, which Maya talked more in Intro to R, which is more optimized towards large data sets. And the second option would be if you need to run a script from the command line, and your script is running specific multiple tidyverse commands over and over again, then it may be a good idea to switch your commands to base R probably, and not tidyverse, because it tends to be a bit slow. There's no issue with this if we are just doing an exploratory data analysis and we are looking into our data and running just comments once or twice. But if you run it multiple times, sometimes it's a bit slow. All right, so there are two basic things we need to know about tidyverse before we go and try to explore our data. So the first thing is a pipe operator. It wasn't introduced in dplyr, but it is implemented in dplyr. So this pipe operator allows us to chain operations together for both convenience and better readability. It works similarly to this operator from Unix. So this is a pipe, and this pipe is just takes what is on the left side and passes on the right side as a first argument. So let's say we want to run this specific command. Like you can see, it's not easily readable, even though it's a pretty simple example. It's not easily readable. If you want to figure out what does it mean, you have to count and go just to the middle of all of these layers. It's like an onion. And then we can see that we actually created a vector of 100 elements here. Then we calculated a mean of all of these elements. Then we round it up to integer parts, and then we change it to a character string. So we have 50 character string. So how would it work if we use pipe operator? If we use pipe operator, we're just going to write comments one by one. What are we going to do? So first of all, we create operator, then we run a mean, then on this we run rounding, and then converting into character. So as you can see, we don't have to use tidyverse in general, tidyverse data types, to see that this is already very useful. So especially if you work with a big data set, then you can run comments one by one, just add another step, and you can check what you're doing at every step. So that's the first thing. And the second thing is the data object, basic data object that tidyverse is using. And it's a tibble, or we can, or sometimes it's called TBL DF, like tibble data frame. Because it is, I'm going to use tibble because it's easier to pronounce. It's actually is a data frame. It's improved or modernized data frame. In tidyverse documentation, they call it more lazy and surly. And this is because tibble in general is not going to do so many operations as data frame does when you read your data. So it's not going to try and force data types, convert some of the data types of your data. And it's going to complain a bit more if something unexpected happens, which is good, because at the beginning of, if we're going to get some complaints at the beginning, it's better than after we do a couple of steps of our analysis, and then we find out that, for example, our dates were converted into integers or something like that. Let's see. So this is how you specify tibble just from the command line. So this is a very simple example. Like a data frame, we specify the numbers of vectors, numbers of columns, and the values. And we can use different data types in the same tibble. All right, how to save it to the value? Well, we can use the basic syntax of R. So we can just save it to the variable as any other variable. But what we also can do is use this trick and save last value that was used in R onto our variable. So here, now we have a table, a variable, which is our table. Okay, how do we make conversions between data frames and table? Well, table builds on data frames, and sometimes, and mostly for most packages, for most modern packages, you can use table in place of data frame, but sometimes you use something more complicated or something older. For example, you need a data frame that you need to pass a data frame to a function, and this data frame requires you to have row names. Tables in general do not have row names, so we will have to convert it to data frame before passing it to such a function. So yeah, so from table to data frame, we just use R, base R as data frame function. Yep, so our data frame is going to look like this. And let's add some row names just to see how it looks like. Yeah, so this is our data frame. We have numbers, names. This is how it looks like in command line. This is going to look a bit different here, and this is our table. So our table, as you can see, has dimensions here and has the data types. So we are just taking a glimpse at it, and we see that these are integers and these are strings. How we would go about converting data frame to a table? Well, we can use as table function, but as you can see, it will by default totally ignore the row names. If we want to preserve them, we need to create a new column which will take values from row names. So here we're going to use row names column, row names name, and here we have our row names. How do we add new rows to the table? This may be a bit simple for some of you, but this is the basics, and let's just go through it. So we can add new rows by an add row command. So here, our table just have these two columns. So when we are adding a new row, we need to specify to which table we are adding it and what are the values we want to add in this row. So this is how it looked like after adding a row. We can see that it wasn't really added. What happened? This is not a change in place, so we have to override our former table with our new table. And now we have a new row. Great. How are we adding the column to the table? So we can still treat table mostly as a usual data frame. So for example, we can test what are dimensions of a table, the same way as we would with a data frame, but using a dim command. And the same way we can also add a new row. So for example, here we are adding a new column called squares with squares of the numbers from the column numbers. There it is. Or we could use tidyverse mutate operations, which works like this. So here we have pipe operator, but we can also just put table in the middle here. So this is how it looks like. We just added the cubes. So numbers raised to the third power. We are going to talk about mutate a bit later on, but this is how you do it, and these are the basics. All right, so when you're working with your own data, you will probably need to load your own data from the file and probably save your data table, your table into the file. when you done like cleaning up your data, for example, or when you change or reshape your data to how you want it. So this is how you do it. This will actually create a new table file, which is TSV, so tab delimited. And we can see here that this is this file. This is how it looks like. All right. How to load a new data. In this repository you downloaded, there is a countries file, which contains, this is just an example file with data that I curated from United Nations data website about estimated populations in different countries. So we can load it. What happened here? So in general, tidyverse gives us an information about how it parsed the columns. So let's see. It says that there is 5 columns that are doubles, so numbers, and there is one column that is a character. Let's see. Well, that would be about right. So this is a character column, you can see here, and these are numbers. If we try to, so this looks a bit different here than it does here. We're going to see in a moment in a bit more detail. So how to read data file without getting this comment. So we can explicitly specify what data types we're going to use in loaded when we are loading file. So we are doing this by specifying call types. There's no information. Great. We can also accept the default infart column types. For most of the cases, this is all right. We are not going to have anything unexpected, and if we do, then tidyverse is going to complain. So this is how we do it, just by accepting the defaults. Great. So this is the first data type. Countries. We're going to go back to it at the very end of our seminar, hopefully. But then we're going to also look into other data set, which is Palmer penguins. If you saw our Python seminar, you probably are already familiar with this data set. So this is a data set of Palmer penguins, so penguins from Palmer archipelago. It's a new alternative to Iris dataset, and it's accompanied by this beautiful artwork by Alison Horst. So we have three. So in this dataset, we have three species of penguins: chinstrap, Gentoo, and Adelie penguin. I hope I'm not butchering these names. Let's see. And it is, in general, it is prepared for work in R. So it's not only pre-processed, but also available as a package. So we're going to attach this package and see what our data looks like. So yeah, so this is our table. As you can see, there's many more rows than we can see right here, 344. This is how it looks like in Markdown. So here we have pages that we can use to look through the data. In general, if you work in console or in usual just R file, this is how our table will look like. So it closes off by default by after 10 rows. Pay special attention to data types here, data types of specific columns. This data was pre-processed, so some of the columns were already changed to factors, which in general we can think about like categorical variable. So this variable has a couple of levels, couple of different options here. It's a categorical variable. What is great about tables is that they are in general easier to look at in the command line, in general in our R console. For example, if you change the size of your console and try to look at the data again, it will only show the columns that will fit here, but you're not going to lose anything because here it says that there are additional columns and what types they are. So it's great. And again, if you are used to, for example, working with Excel and you want to see your old spreadsheet again, you can use a view command. So the general R command that you can also use for data frames to see a whole data set at the same time. I wouldn't recommend it. I think after familiarizing ourselves with tidyverse options, we're going to be able to work without looking at the whole spreadsheet. All right. So here is some additional information. Penguin dataset actually has another table, which is a Penguin row data table, which we are not going to use right now. And here's additional image of this dataset. In main Penguins table, they're using bill depth and bill length to talk about bill measurements across penguin species. In Penguin row, they're using Coleman. It's a bridge at the top of the bill. It doesn't matter much for us right now because we're going to use a main dataset. All right. So we have some data. Let's talk about what we can do with tidyverse. Most of the tidyverse courses I've been to or I saw take you through the commands one by one, and this is great if you want to learn what each command specifically does. However, I would like you to focus first on what are our options, what we can actually do with our data. If you never worked with tidyverse or databases, you probably are not even sure what are the options here that are available to us. So we're going to run very quickly through our options here. And then after this, we're going to try to just use our tidyverse functions alongside the ggplot because for data exploration, because this is usually how you do it. So you go through your data and you use plots to visualize better, to get a better feel of your data. And this is what we're going to do. Let's learn in practice. So here's a couple of images I have for a better understanding of what are possible options. And they were taken from a cheat sheet about working with dplyr and tidyr, which is linked above here. It's a very good resource, so I recommend you to check it out. Especially if you are trying to do something in tidyverse and you don't know why you're getting an error, for example, or which command to use. Okay, so what are our options? So when we are working with data, we sometimes want to subset our data, so we want to only look at specific columns or specific rows. So to look at specific columns, like here, we're going to use a select function. There's also a filter function that allows us to specify subset rows in our dataset. So that we look into just specific rows based on either some complicated logical criteria, which we're going to talk about a bit more, but it is mostly used to just display all of the rows with a value in a specific column. And this is how we can think about it for now. What are other things we can do? So we can order our data, for which we are using our arrange function. And there's additional function that reverse the order. So arrange will show our rows by values in column from low to high. Or we can reverse this. It's useful mostly when you have to quickly check what are, for example, you calculated an expression of your genes and you want to check which genes have the highest expression, for example. Okay, we can also update our data by using mutate, which we already mentioned. So adding new columns or changing existing columns. We can also use, so let's load this graphic. We can also use separate and unite to split values of the column into multiple columns or reverse the process. And we're not going to focus on this a bit more. It's mostly helpful in cases in like this. So in our row penguins dataset, we, for example, have a species. Let's see, what are our options here? So in the row data table, we have our species. And let's see, only unique values. So we have these 3 species, and there's a lot here. In our penguin table, we are only using Adelie, Gen2, and GeneStrap. So maybe we want to split this column by a space and then drop this values and just leave this first one. So this is how we would use separate and unite. Here it's not going to be useful, but just so you know. What else we can do? So we can group our data. It just adds an additional layer of organization to our data set. Usually it doesn't look any different, so we may think that it didn't do much. But if you combine this function with a summarize, for example, which summarizes data, that calculates some statistics for your data set, you can calculate statistics for specific groups and not really whole data set, which we're going to start with pretty soon. So yeah, so we're specifying specific groups in our data set, and then we are creating completely new data table where each group has their own row, and we have some of statistics we calculated. All right, next and pretty much last thing, which is very worth mentioning, but we're not going to use it that much right now, is how to combine data set. And here you can see the similarity to databases. In general, you want to use either join that will preserve data rows in left or the right data set. You can combine data set and preserve only common rows, or you can combine data set and preserve all rows. By rows, I mean here we are going to specify by which we are comparing, and tidyverse would look at this specific column to see if this column exists in both of this data table. Yeah, it's pretty easy to use. It's not that complicated, so don't be afraid. But in this particular case, we're going to focus more on plotting and on our exploration of our dataset that was already pre-processed for us. So we're not going to need this. Okay. So let's see. Let's look again at our data type, our dataset, penguin dataset, or rather, like take a glimpse into it. So this is a command that is very similar to just displaying a table in your in your console. However, here we see a bit more of the records, and what is very important, we have some basic statistics. We see what are our columns and what types columns are. So in general, without focusing much on it, we want to know what we have in this dataset first. This is what we also should do when we work with our own dataset, just identify what you actually have. So here we have different species of penguin, 3 options. They're living on different islands, so there is a categorical variable for this. There are also measurements for their bill length and depth. There is also a flipper length, so a wingspan. Also a body mass, which we're going to treat as indicative of the size of a penguin, just by assuming. I do not know much about penguins. I hope I'm not insulting anybody here. We also know sex of our penguins, and there's also a year the measurements were taken on. All right. So let's see. Yeah. So I hope I'm not talking to myself and you all can hear me now. So we're going to just go straight through to the data exploration. So the first thing, yeah, somebody is here. It's great. If you guys have at any moment, if you have any questions, please ask them on either on YouTube or in Discord channel. I am here to answer questions. It may be a bit fast because I'm just running through tidyverse, but I want to give you a very good overview of what we can actually do. So here, we are going to be interested in species column. So let's subset our dataset. Let's look at our penguins dataset at species. This is just an optional step for exercise purposes. This is how we would do it with pipeline. Amazing. Why we are doing this? So here it may be not so obvious, but let's say your data set is very wide and has multiple columns, and you're going to work on some of them. It's very good to check. In general, you can pass whole data set to a next comment. However, you should always double check. What I'm doing is I'm writing these pipelines, and with each new line, I am printing this to my console and checking if I'm working correctly. So the select in this case would help me look at identify if I actually have the data I think I have in my columns. All right. So yes, so this is how the select works. Here is a good side note. So select have also a couple of other uses. You don't have to just specify one column. You can specify multiple columns. So for example, here we can see species and sex of our penguins. We can also specify that we want to see everything but a species, for example, or but a specific column. And we can also select columns with some more complicated helper functions. So for example, here we're going to select columns with regular expression. So we want to see all of the columns that start with a bill. So bill length and bill depth. And it works. Very great. So as you can see, it's very flexible. Mostly you're going to select this too, but sometimes it's very helpful to just select them by regular expression. For example, if you have multiple patients and you want to select just a subset of them. All right. Oh yeah, and there's additional side note I put here because this was an issue I had when I started learning tidyverse. Is how exactly I go from I selected my column and everything is great, so I can see my penguin species. How exactly I go from a penguin species from this table with one column into a vector, so I can put it into some other functions or do something else with it. Well, let's see. Also pull. I see some comments from Kasia about a pull function, right? Yeah, there's many more functions you can use. So let's see. It's fine. If you know something that is also very helpful to you in everyday life, please just put it put it in the script in the chat channel on Discord, so we can all see. Yeah, there's many more, and I highly recommend looking through some cheat sheets so you can see a whole range of functions. But in general, I found it very easy to do with just these functions I mentioned. That's why I selected them. So yeah, so this is our, so let's look here. So this is our column. Very good. And in general, what I wanted to do when I started to learn tidyverse was just save it on some variable, and then maybe just change it into the vector. It won't work. As you can see, it is actually a list. So I would need to do something like this in species to get a whole vector of this column, which is just inconvenient. But we can use this. We can use specific tidyverse operations to also run this. So, for example, we can deframe it. Here, if I run it with just a head comment, it will show us only first couple of values. So so deframe our table means convert it into the vector. Okay, and something else that I found very, very helpful is just selecting variable in place. So dot here means this dataset I'm using. So from this, I don't even have to select here. I just specify which column I need here. So just select the species common. Yep, we have a head. Great. All right, so let's move on to the exercise before I got so caught up in the tips for using select. So let's try counting our penguins with summarize function. All right, so summarize functions here accepts our dataset, our penguins, and then we specify how do we want to name a new column and what function do we want to use. We can use a couple of different functions. We don't have to use n here. We just want to count rows. So this is what we are using. So here we have 344 penguins. Well, okay, these are our penguins, that's true, but we also already knew it by just checking our penguins dataset, right? We have here a number of rows. So, but we are interested in looking how many penguins we have in different groups. So we're going to use a group by function. In group by, we are specifying a column. We want to so our grouping variable. Let's see, we can use this. Okay, so here, well, it didn't change much actually. Actually, this dataset is ordered, so it would seem that it changed, but if the second row was a chinstrap penguin, it wouldn't move right now. It doesn't arrange your rows, it just adds additional layer of organization. So when we use a summarize count after a group by, we will see a count of our penguins for every species separately. Great. Yeah, this is great and all. This looks very nice. However, you know what would make it even better? Plotting it. So let's move to the ggplot. Yeah, so ggplot is a specific package for plotting. It is one of the most popular packages for creating your plots, and it creates publication-ready plots. So you can highly customize it, and you can create plots out of everything. You can even put your own images into it, as well as plots you create in ggplot, which we're going to see at the end. So how does it look like? How does it work? It has a very specific grammar. So again, so this is kind of a syntax. So let's say we want to plot our data, and we want to plot our data in such a way that on so for our penguins on x-axis we're going to have a species, and on y-axis we're going to have count. This is just a sentence in English language, but it will translate very well into ggplot because ggplot is going to work by applying layers. So I started by saying what data I want to plot, and this is also what we have to specify. We want to plot our penguins data set. Then what we want to put on our axes. Then we want to specify how do we want to plot it. So we want to create bar plot and so on. So we are, in general, we're constructing the plot step by step by adding additional layers, and this provides us with a great control over how these plots actually look like, and we can customize it highly. So I found this very great figure that shows how ggplot works. It is a bit big here, so we're going to look at it in PDF. So this is a knitted PDF version of the same file we are looking at. Let's see. Yep. So this figure was created by coding group in, I think, University of Edinburgh, and it's been made available for everybody, and it looks amazing in my case, in my opinion. So let's say we want to create this type of plot. What would be our layers? So first we want to look into our data and we want to specify what data we want to use. Then we want to specify how we want to present our data. So what variables we want to put on axes, and in this case we want to use a point plot. Then we can add labels, add titles, add additional customizations, and this end up being this great plot of wingspan versus body weight. Oh, this is a great plot. So I wonder if our penguins have also bigger flippers, bigger wingspan, and if they are heavier. Oh, we'll go back to it in a moment. Let's go back to RStudio for now. Yeah, so this is a great resource. I recommend you to check out Coding Club because they also have a couple of tutorials that may be useful for you. All right, so okay, so how do we do it? We do it step by step. First, we want to create our base ggplot object. So we're going to, so this is our data we calculated before. Windows sometimes surprises me. All right, so this is our data, and we're going to pass it to our main ggplot function. We can also do it by specifying ggplot and inside a function, of course, but if we are a data set, of course, but we are doing some operations on it, so we're going to use it like this. All right. Oh, that didn't really work, you might say. But in general, it does work. This is what we wanted to see. This is our, we can think about it as our canvas. We just said that we're going to make a plot out of our penguins dataset. We have not specified what we want to plot and how in this dataset. So our ggplot didn't know what to plot right now. Let's change it. So we're going to add aesthetics to the plot. aesthetics specify what we want to plot. And we are doing this by using AES function. And this function will map some of the variables from our data to specific axes or other parts of the plot. For example, here, color. So what we want to do is specify that, yes, on x-axis, we want to have different species. On the y-axis, we want to have count, right? A count variable. And then how do we want to color it? Let's color each bar according to the species. So each bar of different color. All right, let's run it. Yeah, so you can see that it definitely worked. The x and y axis is displayed as we expected it. However, we do not see our data. And this is because we have not specified how we want to see our data. So we haven't specified yet that we actually want to see bars and not, for example, points. Yeah, so let's see. So how to specify how to display our data. To do that, we are using different geoms, so different geometric objects, geometric layers, and we are we are the most important part here. I got a bit distracted is that we want to add them to layers that we already have. So we are using a plus here. Believe me, I worked with it for such a long time, and I still sometimes put a pipe here, which we really shouldn't. It won't work. And it's so frequent that ggplot even going to ask you, are you sure that you are putting a plus there and not a pipe operator? Well, sometimes I do. Okay, so here, because we want to show, why did we choose a bar plot? We want to show a difference between a categorical variable across different groups. So this is why we're choosing this just simple bar plot for now. We're going to talk about types of different plots a bit later on. So here we specify the geom bar. This is what we want to run. Great. Yeah, so there's an additional parameter here, and this is because we are using geom bar. We are using this. So yeah, some of you that know tidyverse may wonder why we are using our summarized data, because we actually could just pass our penguins dataset and specify here, specify that we are using just our X values, just our species, and geom bar would by default count all the values for us. But there is a reason for it, and this reason is another geom that we're going to add in a moment. So that's a spoiler. For now, we just add geom stat. Yeah, it looks great. We have a plot. However, as you can see, the colors are not quite all right. So what happened? We have specified here that we want to color it by species, but in ggplot, we actually are using color and fill to specify different colors. In general, color typed either this or this way defines the color of a geom outline in general, and fill specifies the color the geom is filled with. So in this case, we would really like to specify fill, or both fill and color. So let's correct it. Yeah, so here we have fill. All right. Yeah, so this is amazing. We already have our first plot, and it looks great. So I want to do a quick side note about aesthetics. Most of the people, when they're starting to learn how to plot, they put aesthetic functions in classical place in our main ggplot function. And this is great, and it will work. However, if you are doing more complicated plots and you are specifying, for example, multiple geoms that are using different variables, it is very good to move static function into specific geom bars, and you can do it without a problem in ggplot, because this way you're just keeping track of which geom is actually using what, and I highly recommend doing that. So in this case, we can just move it here, and the plot will be the same. Yeah, so here it's not yet changed. Let's see, like this. Yeah, great. So we have our plot. So let's talk more about mixing different geoms. So we can try. This plot is actually pretty great already, but we want to see here we have our counts, and there is a scale here, and because the range is quite high, we cannot see quite easily how many penguins are here. So let's add labels to our plot. Here I'm going to use geom label, just because it looks a bit nicer. However, we can also use geom text, which is more flexible if you want to do something else than just add numbers in the top of your plot. You want to, for example, annotate your points or add some additional text on the plot. You can use geom text. Okay, so we are adding additional geom, and here we are specifying that where our label, we want to place our label at x-axis by species and on y-axis by count, and then as a label we want to use our count variable, count column. All right. Yep. So this looks very good. We see how many penguins we have of each type, but there is so much more stuff we still can do to this plot, and we would spend ages if we would like to just go through all of the possible customizations. I'm not sure if it's even possible, because we are literally just using our imagination to think about different things we can put on this plot. So I created a list of just from experience of customizations I use frequently and that are highly useful. I just quickly look through it. So we can try updating our axis labels and adding a title to our plot, which can be done with just one function or with specific functions. Let's say we can have we can add transparency to our plot. So in this case, we would see a grid a bit better if we make them a bit more transparent. This is done with alpha parameter. We can change a color palette, and I would recommend changing the color palette to color blade friendly palette. There is a package we're going to use called later on. This package is called PNW colors. There's also another package I highly recommend, which I'm going to put in here. It's ggSci. So this package contains a couple of popular color palettes, including a nature journal color palette. So we can already make your plots look a bit more professional. The easiest way to customize your plot is to change whole theme of the plot. So themes are actually sets of different customizations that were created together. So different styles you can easily apply to your plot. There's a whole bunch of them. Let's see. So here I highlight some of them. So there is so let's see about a couple of options. All right. Yeah, so this is our default theme, but we can easily, just by adding one comment, we can change how our plot look like. If you want to plot it on a dark background, you can do it. then I would recommend changing the color of the points. You can minimalize elements you don't need. So for example, additional axis here, or you can remove grid if you want. Yeah, so that's data from 70s, and it looks like it's data from 70s in this way. Or maybe you can remove axis altogether. Sometimes it's helpful. And there's a lot of different options. So that's a spoiler for later. A lot of different options that we can use. Okay, let's see. Yeah, so we're going to add a theme in a moment. We can also edit our themes and customize it more. So for example, change legend placements, remove it altogether if it's not needed. For example, here, we already know which species is which, so we actually don't need a legend. I'm going to just leave it so that you know how it looked like. But other than this, yeah. Or change our fonts. Here, because we're doing a bar plot, some of these are not applicable, but but comments I'm using a lot and customizations I'm using a lot is, for example, changing axis limits. So if you're looking at points and you just want to look at a certain range, then you can do it with these two functions. We can change the shape for our points. We can add error bars, or I would highly recommend adding ribbons instead of adding bars, which is more aesthetically pleasing and easier to compare between different lines. And yeah, and we can even fit models to our plots, which we'll also see in a moment. All right. So we're going to use a library I mentioned. And we're going to customize our plot a bit. Yeah. So this should be pretty self-explanatory after what we talked about. But what we did here is we actually add some labels. We add a new theme. We customize the theme by placing the legend on the bottom. As you can see, now it's here. Yeah, I can collect. Okay. And then we used our different palette. So in this case, we used this palette from this colorblind friendly palette to display our data. Cool. It looks much better, in my opinion. We're going to save it. It's great. Let's save it for later. So here, the last plot. That's a highly frequently used function. All right. So let's talk about a bit about facets. So what would happen if you want to look at our penguins separately based on sex of the penguins? So we want to see a plot of our male penguins on the left and female penguins on the right. We can do it very easy with ggplot with functions such as facet wrap and facet grid. And they will split data into combinations based on combination of multiple factor values, or just one factor value, like here, based on sex. We can split it into multiple panels. What's very important is that all of these small plots, we're going to represent the same graphical idiom, or the same geometrical type, and they're coming from the same data. So this is different than just combining different plots and looking at them side by side, which we're going to see later on, hopefully, if I get to it. All right, so here we just added one function, facet wrap, and we specify that we want to split based on the variable, on the sex variable. All right, so this looks very nice. We have female penguins and male penguins separately, and even counts got updated. So ggplot knows how to do it automatically. However, here we discovered that some of the penguin sex was not identified. So it's a good opportunity to practice some data filtering. Let's try to filter out this missing values before we plot them. And we're going to do it with a filter command. All right. So yes. So we are using filter command can filter out based on just one logical parameter or multiple logical parameters. So here we are using function isNA, and this function actually returns logical values. So if we run it just by itself on our penguin on this penguin penguin sex, so this is the vector of from our column, from our table, we're going to get logical values, so false or true if it's NAs, so missing values or no. And this is what we're going to use to filter our rows. Let's see, what are our how many penguins? How many missing values do we have? So there is 11 penguins with not specified sex. So we need to filter out these rows. So we just need to reverse this condition. So we want to check which of the rows do not have NAs in this specific column. And we are doing this by exclamation mark. Right, so if we run just this, then we're going to get all of our penguins that do not have missing values in the specific column, and we want to group it and summarize it. Yeah, there is no rows. We can see that there is no rows with NAs here. So it worked. Let's plot it. Just using tidyverse, we just need to specify this one column. We're just adding one additional operation we do before plotting. And that's it. Our plot looks good. All right. Let's talk a bit more about filter. Like I mentioned, we can use just one variable of multiple variables and multiple conditions, as long as we are using logical conditions. So here we're going to check if we're going to filter based on categorical variables. So we're going to check if species is specific, just one specific value of categorical variable. We can filter based on the threshold, so we can look in at some of our continuous variables and set fixed threshold, or like in this case, we're setting moving thresholds. So for each penguin, we check if bill depth is higher than half of bill length. So let's say a proportional bill. And as it happens, 35 penguins have these proportions of bill. We can filter based on multiple values in just one variable. So here we are checking species, if species is either Adeli or Gentoo. Or we can filter using multiple different conditions. So here we are specifying both that species. We want to see a species Adeli and island Torgerson. Great, there's 52 penguins that live or lived there. Okay, great, so we made our first plot. It's great, we saved it for later. Now let's try to do something else, something more complicated. So remember the ggplot figure. It checked if birds of a bigger wingspan also have higher body mass, so are bigger. Yeah, so in our case, let's check if our penguins that are heavier, so have higher body mass, have longer flippers. So we have flipper length column. Yeah, so we are interested in these two columns, and probably species. We're going to look at different species separately or together. Let's see. So let's just do some simple data exploration. So we can, for example, look and see what species have the highest and the lowest body mass. So here, the highest body mass would be all the Gentoo penguins. That looks promising. Maybe Gentoo penguins are in general higher. The flipper length also seem a bit higher, so we'll see. Yeah, we can also remove this to make an ascending order and see, oh, the smallest penguins. Oh, there is both chinstrap and Adelie penguins here. Flipper length is lower, so who knows, maybe it also colorates. Let's check how body mass and flipper length looks across the species. So here we are grouping by species, and we are looking at average mass and average flipper in different groups. It also looks promising. It looks like Gentoo are definitely the biggest birds. However, as we know, when we are calculating average, this may be a reason that this average maybe this mean may be higher because of some outliers. So this still does not tell us much. Yeah, so here I put some additional information about Summarize. So it can do so much more than just counting penguins and calculating averages. We can calculate multiple different statistics in one command. And for example, here we are checking average, minimum, and maximum mass for each species of the penguins. And also we are counting them. And it can even accept more complicated syntax. For example, here we're going to summarize our dataset across all of the numeric columns, and we're going to calculate an mean out of all of them. Yeah, so I removed a year column because calculating an average of a year does not make any sense. However, here we can see that it calculated average for all of these numerical variables, so it is pretty flexible. All right, so we looked at averages. Let's see also if, because we are looking at both body mass and flipper length, it seems that our Gentoo penguins actually have the higher flippers, the larger flippers, and the highest body mass. But let's calculate some ratio. We can use mutate that we already used to create a new column. So here we want to create a ratio column by dividing body mass to flipper length. And here is our new column. It divided one value by the other for each penguin separately. So this is our new data. Let's see how it looks like. So if we add summarize, we can go ratio. It should be ratio. Let's calculate average ratio. All right. Yeah, it seems definitely promising, but you can only do as much just by means. And what would improve our data exploration is, of course, creating a new plot. So let's do it. Let's plot the relationship between two continuous variables here. So a flipper length and the body mass. And exactly like it was done in this figure, we're going to use points to specify all of our data points of all of our penguins. Yeah, so let's check if we have any missing values, because we already know that it may be the case. Yeah, we have two penguins that do not have any of these measurements, so we will need to filter them out. All right, let's filter out these penguins. And then we're going to create ggplot, just general ggplot object, and we want to use geom point. Right. So this was much quicker than the last one because we already know the basics of plotting. So we want to look at a body mass and a flipper length, so two continuous variables, and we have a dot for each penguin. It looks very nice. It seems like there's definitely some correlation here. And also, as expected, gentoo penguins are clearly the biggest birds, so they have the highest body mass and the longest flippers. So here, what is very helpful is we could also fit a line through this, so based on linear model, to show a trend in these layers. Of course, you need to remember that in general, plotting is not equivalent to statistical testing. However, it helps. It really helps in building hypotheses and just exploring your data. So here we are just looking. It looks like it's correlation. If we actually had to calculate it to be sure, to calculate how much correlated they are, but we can easily see that they are. All right. So we're going to add this line with geom_smooth, and we're specifying that we want to fit a linear model to our data. All right. Yes, it says what formula is it using, but yeah, it looks like it fitted perfectly. There is a clear ratio. There's a clear trend in our data. However, we could, of course, customize this plot more, and especially it would be good if we could fit our model separately to each species to see a trend line for each species of penguins separately. All right, let's do this. So here I'm doing a couple of customizations that are already known to us. So I'm changing the color palette, changing the position of the legend, adding new theme and new labels. What is very important here is that I increased the size of the points, and I grouped our geom_smooth by a species, by which I'm going to fit the linear model separately to different species. Right. Seems very good. It looks much better, and it fits our plot from before, so we can save it for later. All right. So we already have two plots. They look very good, in my opinion. However, I hope you're following, and I hope that it all is clear. You can always go back to it later on. If you have any questions, again, please ask them. Okay. Okay, we need to move on. So what is the, let's look at something else. So let's look at the distribution of just one continuous variable across different species. So this is a different case than before. So we want to look at, let's say, bill length across a species. So I wonder if penguins that are actually bigger have also bigger bills. So let's see. Of course, we are starting by just exploring our data. So we can check. Let's summarize. Let's calculate the average bill length across different species. Yeah, it looks like this may be the case that they actually have bigger bills. However, you can see that chain-strap penguins actually have also quite big, quite long, I guess, bills, even though they are, as we already checked, of similar sizes as Adelie penguins, who have much smaller bills. All right, let's plot it to see it better. So let's just try. Okay, so here, what actually happened? So what happened is we tried to use geom points, which kind of makes sense. We want to see different data points separated by species. So why wouldn't it work? So the issue here is that we have a categorical variable. So it just put all of the points in the line. Can somebody tell me, like, let's do a quick check if everybody is awake and somebody is listening to me. Can everybody tell me why putting points on the line is not a good idea? Let's see if I get any extra response. Oh, somebody is writing. Let's see. Yep, Anna Maria suggested that because they overlap, and this is definitely what I was going for. So yes, we are not sure that we are actually seeing all of the data points. They may be overlapping, so this is definitely not what we want to see. We should probably use different geom, but what should we use? And the answer to these questions is not always so obvious. The most important thing that we have to consider here is variable types and what we want to actually show. So here we are showing a relationship between categorical variable and a continuous variable across different groups. So this is one thing. We can also take a look at this, the second beautiful figure from the coding club, and maybe again in the PDF, so it's a bit smaller. Let's see. I just scroll through our beautiful plots here. All right. So this is just one of the example of how we can of different types of plots and how we can select the plot. So in our case, we are looking at the distribution of our continuous variable, the bill length, across different groups. So yeah, let's try a box plot. However, there's actually a lot of different types of plots, a lot more than they are here. So, for example, there are line plots that you could use either to show relationship between continuous variables or, for example, a time series. And there's a lot of different things you would like to consider. For example, like who is going to look at your plot later on? So what is your audience? And also, there's a personal preference, I guess, between using, for example, box plots and different variables. Let's see. All right, let's go back to our plot. So let's just use box plot for now. We're using geom box plot, and it actually looks pretty nice. We can see that in general, Adelie bill is much shorter than both of these different species of penguins. So this is an improvement. However, we could also add something to it to see specific data points along our box plot by adding a variation of geom point that will allow us to see more of the observations and get a better feel of our specific data observations. And this is geom jitter. And here what is important to see is because I'm adding dots on top of my box plot, I'm actually removing an outlier from a box plot so that it doesn't create a dummy point for a dummy additional point for our data. Also, geom jitter is work in such a way that it takes a position of points and it adds a noise to it. So we can restrict variation of this noise so that it doesn't change in height, and we can actually compare our points. But it changed in width, so we see more of them. Let's see how it looks like. Yep. So this is it. So these are our specific penguins. The height is the same as it was in the just the point plot, and they are not overlapping. And we can also see a box plot, so for example, our mean value of bill length. Yeah, so we can see that there are some outliers, but in general, the trend is pretty clear. All right, let's customize our plot and finish with this specific part. All right. I'm adding some basic customization as before, changing the color palette, changing a geom position. For bottom, that's just a personal choice. And then I'm changing a theme, adding labels. Here, I also added some transparency for the plots, so we can better see box plot below it. You can add more transparency if you want to. I also increased the size of the points so they are better visible. Oh, we're getting very good at it. And you can see that we're just looking for tidyverse, just exploring our data, then thinking about our variables, what we want to see, and then plotting it to make an observation. And this is, in general, how I work and how I recommend you to work. So let's save this plot for later. All right, so I specified before that we are going to look into something different too, something different than facets, which is combining different plots that are coming from different data. So we have created 3 different plots for this Palmer's penguin dataset, and we're going to try to look at them together. And there's a lot of ways to do it. I would say that the easiest one would be using a ggArrange function from this specific package that adds some extras to our ggplot functions, ggplot package. There are other options. For example, you may use grid extra. I think this is what it's called, additional package. Or if you're making plots for figures for a publication, I would recommend using a Ggplot, which works on top of the ggplot, just takes ggplots and then allows you to make some even more customizations. However, for our case, ggArrange seems to be the easiest way to go, and I'm using it the most. And I think we can work with it here. So let's attach our package. The input here is our specific plots we saved on variables before. So we have our 3 plots we want to specify how we want to see these plots. So here there's a number of rows, a number of columns. It will go in the order that we are specifying here. And there's some additional things we're adding here, like labels for the plots, the aligning of the positions, and we want to have a common legend for all of them and if you realize, we can do it because in each of these plots we are looking at separate species and we have the same colors for each species too, so not an issue. All right. Yeah, so here we have an analysis that we did today. We can be very proud of ourselves that we looked at all of these different variables and all of the different relationships in Palmer's dataset. I also have something extra for you, which is how about we add something additional here? We have some space, so why not? So I attached an images file. I attached also a logo of Palmer dataset. So we're going to add an image just from the file, just a PNG file. Right. Yep. And this is our result. In general, this is mostly it. There is just one additional thing I would like to show you, and this is something that we didn't have to use right now, and this is reshaping your data. From observing how beginners work with R, I think reshaping the data seems to be one of the most weirdly difficult things to imagine. But the idea is pretty easy. We just sometimes people have problem with thinking about why we want to reshape our data, why we actually want to do it, why we cannot just work with our data as is. And there's multiple reasons. So our penguins dataset actually, as I mentioned before, it is already very pre-processed and prepared for our analysis, especially it even is in a table already. We just have to load it, attach it, and load it. And that's it. And it was prepared for our analysis in such a case that our observations were in rows. So each penguin was one observation, and we looked at, and it was in a row. So we really didn't have to do anything. However, when you are using your own data, frequently there is a need to check if you actually have your observations. Where do you have your observations, in rows or in columns? For me, something when I work, for example, with gene expression, this is something I need to do over and over again. Sometimes I need specific genes in columns, sometimes I need specific genes in rows and patients in columns. You never know. You need to check it over and over again. And this is very important in plotting the data because, as you saw, we are working on an assumption that our variables are in the columns for ggplot. So for example, let's go back to one of the plots. Here we have a column species and column bill length, and here again is column species that we're actually using as a variable for our plots. But sometimes this is not the case. And then we need to reshape our data using these two functions, gather and spread. Let's see. So remember our countries dataset we just loaded ages ago, it seems. So this is our countries dataset, and this is something that we would call a wide dataset. So this is a wide dataset. There is every observation there is different variable in different column, and here we will have to reshape it. How? Why do we want to reshape it? Well, it's how to decide if we actually want to do it. Well, we need to think about what we actually want to do. So let's say we are interested in seeing a line plot. So the change of population over time in separate countries. And to make things extra complicated, let's look at the total population. And for the purpose of the plot, let's assume that adding females and males will give us a full population, a total population. What variables would we need to do such a plot? First of all, on x-axis, we would want to put a year. So this is first variable. We want to have year. We already have it here, so it's fine. On the y-axis, we would like to put a population, and this is something we do not have in one column. And we will need also a column name country to specify our grouping variable. All right, so how to reshape our data? So yeah, let's run countries again to see it better. Okay, so to change the wide dataset into long dataset, we're specifying the variables. Our key is a variable we want to put in our key column, and the value is a name of another column where all the values will be put on. So in here, population. here we also specify that we do not want to change the year and the sex column in this case. So this is how it works. It created a column name country for which all of the column names are used, and then population for values. What would happen if we wouldn't specify that we want to ignore these two columns? Well, it wouldn't work pretty well. In this case, it would put the sex and the year variables in the same population column. Well, one of them here, one of them here. It is just, well, values here and names here. Excuse me. And this is, in this case, it is not what we want to do. So we want to ignore these two columns. And here is our populations. Great. So this is what we're going to use for our plot. So let's save it. And in the meantime, let's check how to revert the situation. So if we want to take this long data set and go back to the white data set, we want to use a spread command. So in the spread command, we also specify a key. So that would be our country column. We want to change our country column back to the column names. And values that we want to populate these columns with are from this column, the population column. And you can see that here I don't really need to specify which columns to ignore because I'm only using these two columns to create new data. So this is how we do it. And here is the plot we want to make with some additional customizations. I mean, you're already masters, so I'm sure you already know what we are doing here, but I changed a bit. So here is a different palette color because why not? Different legend position. And we are creating, actually, these are two geoms. So one of them is geom line, and the second one is geom point, which just specifies geom line will connect all of the observations, and sometimes we want to specify that here we have just 3 different years that we are seeing. All right, so that would be it, I think. I think these are most of the operations that are needed. Of course, ggplot is a wide resource, and the same with tidyverse, and there is multiple different columns. For example, pool comments. For example, pool, as Kasia specified in the Discord chat, and you may do much more with it. You can do much more customizations if you need it. However, I think you can do most of this with a couple of comments that we used today. If you were following along and you were making notes, remember that you can use neat here to create your own PDF. Depending on your system, you may need to install some of the packages to be able to do it. Other than this, the repository is going to stay as public, so you're welcome to use it at any case. And if you have any questions afterwards, go to the Discord channel and ask them there. And some of us will answer you. And that's it. Thank you.